Hi, welcome back. Sorry these videos are a little short. I'm trying to getting over something, and I don't think you want to hear me coughing the entire time on these videos, so I'm trying to do them in kind of short little bursts here. I can't go very long without hacking up a lung here. So let's continue on. Here we have number 5. I'm going to try to do this whole problem here. As you can see, some of it's starting to be a little bit more repetitive, so I've have part 5, part C already kind of filled out just to help with getting through the video a little quicker. So number 5, we have the number of hip fractures in menopausal women is currently a cause for concern in orthopedic research today. One study is focusing on these events following a group of 1,700 women for 15 years and sorted out the number of fractures by how many women experienced them. The following table summarizes their results. So here we have the number of fractures over 15 years and the patient. So this would represent 1 fracture, 2, 3, 4 fractures, and how many women experienced this over 15 years. So part A wants us to find the proportion of women who had 2 or more fractures. So for this one, we just find how many women had 2 or more fractures. So what we're going to do is we're going to add up the number of women who had 2 or more fractures. So the number of women who had 2 fractures would be 524 plus 211 plus 176. And when you add that up, you should get 911. Okay, because we're trying to find women who had 2 or more. So 2 or more fractures. So be very careful with the wording on the problems. Make sure you understand what we're actually doing here. So women had 2 or more fractures would be 911. You take 911, divide by the total number of people, or women specifically, in this population. So that would be 1,700. When you divide it out, you'll have 0.5359. So the proportion of women that had 2 or more fractures would be 0.359, or 53.59%. Next part is, what is the expected value for the number of fractures seen in the study? So here we have our formula for the mean. So anytime you see expected value or expected number, it's asking for the average. So mu equals the sum of x times the probability of x equaling x. So for this one, we have how many number of fractures there are, but we don't know is the probability, right? So we're not given the probability, so we actually have to figure out the probability for each number of fractures. We figured out the probability of fractures for women that had 2 or more fractures, but we need to know the probability for each of these fractures. So what you have to do is you have to take each one of these numbers and divide by 1,700, the number of fractures by each one. So when you divide all these out, you'll get the proportion or percentage or the probability that's associated with it. So for the first one, 0.4641, 0.3082, 0.1241, it was 0.1035, and that is the probability for the number of fractures each woman had over this 15 years. So now we have the probability. Now we can plug all the numbers into our formula. And you have 1, right? Number of fractures, 1 fractures times that probability of 0.4641 added to 2 fractures times the probability of having 2 fractures added to 3 times the probability of having 3 fractures added to 4 times the probability of having 4 fractures. When we do and work all this out, 4641, 0.6162, 0.3723, and 0.414. When we don't do all the math and we add these all up, right, we're summing them, sigma sum, and we're going to get 0.8668, and that is the expected number of fractures to see that we'll see over these 15 years with this cohort of women. Next, part C is what is the variance of the distribution. So in order to do the variance of the distribution, remember the variance is the weighted average of the squared distance around the mean provided the probabilities around it. So here we have our variance is going to equal the sum of x minus mu being the expected value or average squared, times the probability of x times x. So we have 1 minus our mu. Remember, one thing that you might want to start really getting into a habit with is when you figure out an answer, write what that equals, right? So we're figuring out mu in the first part, and then when we get our answer, that equals mu. So that way when you come back around, you know where the values are. So 1 minus mu squared times the probability of having one fracture. And when we do this for all the problems here, when you work it out, you'll get the corresponding value shown here underneath. And then when you add them all up, you'll get your variance for this distribution when you add this all up. So our variance equals 0.9846. And remember, that is now the average weight of the squared distance around the mean. That is what our variance is. So this is the average weight of the squared distance around the mean provided the probabilities that are given. All right, my voice feels pretty good still, so let's keep going on to number 6. So suppose a new surgical intern operates on each patient undergoing a procedure that has current estimate success rate of 76%. The following table illustrates the total number of possible successes for the intern in his or her corresponding probabilities. So this is just very much like the one we did in the very first page, with just some different numbers and for some practice. So when we're trying to do the expected value and work them all out, I'm going to give you the answer, and then I'll work out all the math, and you'll see that on the final sheet, but you should get equals 0.051 as your expected value. And remember, when we're doing then solving for the variance, you're going to take the number of successes, so probably 0 successes minus the mean squared times the probability of 0 for this one, and we would do this for all of them going through. This is going to give you 0.2510. So once again, I'll have all this worked out, but for the sake concern of time, I'm just going to kind of go through this, and when you add them all up, your variance here should equal 3.2098. And then how does this intern performance compared to current success rate? We take our average that we got, divided by 8, you get 0.6263. That is less than the 76% success rate they're already seeing, so he's not performing nearly as well as they're expecting him to. Okay, I'm going to pause the video here, and then I will do the last part in another video.